Hello everyone, this is Sudipto from Technical Potpourri, and today I'm going to talk about Kubernetes basics, the things that you need to know to start your Kubernetes journey. Today I'm going to talk about nodes, cluster, pods, container and deployment. So let's start. So what is node? A node is the smallest unit of computing hardware in Kubernetes. It is a representation of a single machine in your cluster. In most production systems, a node will likely be either a physical machine in a data center or a virtual machine hosted on a cloud provider like Google Cloud Platform. In GCP, node is nothing but a virtual machine hosted on a Google Cloud Platform. This above brings new flexibility that now each node can have their different CPU and RAM resources. With that, let's move to the next one, which is cluster. Now, working with individual nodes can be useful, but it's not the way how Kubernetes works. In general, you should think about that a cluster as a whole instead of worrying about the state of individual nodes. So in Kubernetes, nodes pool together their resources to form a more powerful machine. Cluster is nothing but a collection of nodes in Kubernetes. So when you deploy a program onto a cluster, it intelligently handles a distribution of work to the individual nodes for you. So if any nodes are added or removed, the cluster will shift the work around as necessary. It should not matter to the programmer to know which individual machines are actually running the code. It's all will be maintained by the Kubernetes and the cluster. Now let's talk about this persistent volume. Because programs running on your cluster are not guaranteed to run on a specific node, so data cannot be saved to any arbitrary place in the file system. If a program tries to save a data to a file for later, but is then relocated to a new node, the file will no longer be where the program expects it to be. For this reason, the traditional local storage associated to each node is treated as a temporary cache to hold programs, but not a permanent location. For example, if you are running a program at node 101 and try to save some data, and try to access the data at a later point of time, there is no guarantee the program is still running on node 101. The program can now run on node 301 and the data that you saved earlier is not available to you because the data is a cache data. It's not a permanent data. It's a temporary cache to hold the programs. To solve the problem, we literally need to store the data permanently. And to store data permanently, Kubernetes uses a persistence volume. So while the CPU and the RAM resources of all nodes are effectively pooled and managed by the cluster, persistent file storage is not. Instead, local or cloud drives can be attached to the cluster as a persistent volume. This volume provides a file system that can be mounted to the cluster without being associated with any particular node. So the thing that you need to understand, if there is a storage linked to individual node, that's a temporary cache. That's not a persistent volume. Persistent volume can only be linked to the cluster, not to the individual node. With that, we'll move to the next one. So let's talk about the containers. So programs running on Kubernetes are packaged as Linux containers. It allows you to create self-contained Linux execution environment. Any program and all its dependencies can be bundled up into a single file and then shared on the internet. Multiple programs can be added into a single container, but you should limit yourself to only one process per container if it is possible. It's better to have many small containers than one large one. So with that, we'll move to the next one. So let's talk about the pods now. Pods are the smallest deployable units of computing. It is a group of one or more containers with shared storage and network resources. As you can see in the screen, we have pod 1 and pod 2, and it's basically containing one or more containers. So in pod 1 we have 2, in pod 2 we have separate 2. So pod 1 containers and pod 2 containers, they have their own shared storage and network resources. So pods are used as a unit of replication in Kubernetes. So if your application becomes too popular and a single pod instance can't carry all the load, Kubernetes can be configured to deploy new replicas of your pod to the cluster as necessary. Because pods are scaled up and down as a unit, all containers in a pod must scale together. So for example, in case of pod 1, if I want to scale up pod 1, all containers, which is basically 2 containers inside pod 1, will also scale together. Can't scale individual node, it has to be all together. So this leads to the wastage of resources and an expensive bill. That is why to resolve this unnecessary bill, what you need to do, pods should remain as small as possible, typically holding only the main process, and it should be tightly coupled with the helper container. With that, let's move to the next one. Let's talk about deployments now. Pods are managed by one more layer of abstraction, which is called deployment. The main purpose is to declare how many replicas of a pod should be running at a time. When a deployment is added to the cluster, it will automatically spin up the requested number of pods and then monitor them. So if a pod dies, the deployment will automatically recreate it. Using a deployment, you don't have to deal with pods manually. You just declare the desired state of the system and deployment will manage it for you automatically. Let's talk about this K8s. What is K8s? We always hear like Kubernetes and people refer that as K8s. K8s is nothing but the first is K and the last is, and in between we have 8 characters. So that's why it called K8s. It's just a funny fact which I thought I'll share with you. So I hope this video is helpful. So in my next video, I'm going to show you how you can configure node clusters, container pods in Google Cloud Platform. So please subscribe to my channel so that you get notification about all my upcoming videos. Till then, thank you. Bye bye.